let's get some live waveforms. So what you're going to do in the lab to get a live waveform is you're going to connect your probe to this probe compensation out. And so now you can still see my voice, sometimes on channel 2, and you can see this square wave down here on channel 1. Now the problem with the square wave on channel 1, as you can see, is that it appears to be moving around. And that's because it's not triggering. What does trigger mean? Trigger means that we determine an event that allows the screen to freeze. And on a waveform like this, so I'm just going to stop this for a second. So on a waveform like this, you can define an event by saying you want to look at a rising edge, or you want to look at a falling edge. So a rising edge would be going from 0 to 5 volts on this waveform, and a falling edge would be going from 5 volts down to 0 on this waveform. So that would be the edge criteria. And then there would also be a voltage criteria. So to set the edge criteria, you press this button to get to the trigger menu. So trigger menu. Press that button. And now you get a menu over here on the right hand side of the screen. And right now it says we're triggering on an edge, and the source is channel 2. But this yellow waveform is on channel 1. So if we want to trigger on that, we have to change that source to channel 1, and we press this button to do so. So just keep pressing until I get to channel 1. There's channel 1. So now I'm triggering on channel 1. Now the voltage criteria would be somewhere between the bottom and the top. So I know this is a 5 volt waveform, so I'm going to set the trigger level. That's this knob here. So it's, trigger level is the knob all the way over on the right hand side. And I'm going to turn that. And as I turn that, you notice that there's an arrow on the right hand side of the screen that moves also, and that this number here that represents the trigger also changes. So I'm going to set that for right in the middle of my waveform approximately. So I set it to 2.6 volts, which is halfway between 0 and 5 volts. Now when I start the oscilloscope acquiring again, the waveform should be frozen. And there it is. So sometimes if your waveform is too small, the trigger is not going to work properly. So we try to make the waveforms as large as possible on the screen. And the way I did that was by changing the scale for channel 1. Notice the channels are color-coded. Channel 1, the button is yellow, and the waveform we see on the screen is yellow. Channel 2 is blue, and the waveform we see on the screen is blue. One more thing about the trigger is that the trigger determines where 0 volts, where 0 time is on this waveform. So the arrow up on the top indicates where 0 time is on the screen. And I can use this horizontal position control to move that to the left and to the right. And as you see, as I move that, the waveform also moves. Okay, so now we've got a waveform and a voltage criteria. Now we're triggering at 2.6 volts, and with our scale setting the way it is, 1 millisecond per division, the waveform looks like it goes from 0 to 5 volts instantaneously and goes from 5 volts down to 0 instantaneously. But in reality, it does not. If we look close enough, we'll be able to see exactly how long it takes for this waveform to go from 0 volts to 5 volts by changing the scale. So the horizontal scale control is here. Right now it's 1 millisecond per division, but let's see what it looks like at 1 microsecond per division. So 500 microseconds, as you can see, as I go step by step, now that rising edge that looked before like it was going straight up and down, we can see that it actually takes time for it to get up to 5 volts. And we can change the scale even more. So we're changing the horizontal scale, and we're getting just that rising piece of the waveform. Now the thing I want you to notice is that as I change the trigger level, so if I move the trigger level up, I'm actually changing the trigger event to something that's around here, to something that's around here, and that will make the waveform move to the left because time equals 0 doesn't change. So watch, bring the trigger level up, waveform moves to the left. Bring the trigger level down, waveform moves to the right. And it's all because I'm changing the criteria that defines where time equals 0 is. So that's a little introduction to the oscilloscope, and I hope you watch this before the lab, and this will help you get through the oscilloscope lab. Thanks.